Hello and welcome to your second half of your 310 task here. So let's go ahead and try number 5. So when you look at this function, let's first off, we definitely know this is an even function, right? Because they both go in the positive direction. Right, that one goes up, this guy goes up, they're both heading up. So we can even fill these in right now, both going positive. Then we can find our roots. So we have a root right here, which would be 2, and it has a multiplicity of 2. So we could write 2 twice. And we have a root of -2, has a multiplicity of 2 as well, right? There's that bounce point there, so we're going to write that guy twice. So when we write the function, we can say y equals x minus 2, that's accounting for this guy, and this guy, and then we have to put a square, because it has a multiplicity of 2. Then we're going to do x plus 2, to account for this guy. Remember, we switch the signs, and of course we add a square. So then they also told us that they're also asking for the domain. So looking here, your domain is going to be all real numbers. Now for the range on even degree polynomials actually is not all real numbers. What you have to do is you have to look for the lowest point. And here, right, this function does not go below 0. So the range here is actually going to be 0 to positive infinity. All right. Cool. So that's that for number 5. So let's go ahead. We're going to take a look at number 6. Now we're going to do number 6 here. So first, they're asking for this in factored form. So this one looks kind of tricky. If we're looking here, we definitely got a root at -2, which they gave us, right? But then if we look at the other roots, they don't go through nice numbers. So that tells us that we're going to have those irrational roots where we have a square root in there. So in order to find this, they gave us a root and they gave us a standard form. We're going to go ahead and do division. So if the root is -2, we know that a factor is going to have to be x plus 2. So we're going to go ahead and do the division. So we've got x plus 2 divided by, and then we've got x cubed minus 2x squared minus 7x plus 2. So we're going to have to go ahead and do long division here. So we're going to do x cubed divided by x gives us x squared. We multiply, we get x squared plus, we get x cubed plus 2x squared. Then we change the signs. We get minus 4x squared, bring down the -7x. -4x squared divided by x is going to give us a -4x. We do our multiplication. We get minus 4x squared minus 8x. Change the signs. And we get x, bring down our 2. X divided by x gives us a 1, so we're going to do a plus 1. And we end up with x. Oh my goodness. I don't know where that 1 came from. That should have been a plus 2. Sorry, guys. Bring the plus 2 down. We multiply. We get x plus 2. Change the signs. We get 0. So this is what we end up with here. Now, of course, you should first check to see, well, can I factor this? This is not factorable. There's nothing that's going to multiply to give you 1, add to give you -4. So for this one, you're definitely going to have to use quadratic formula. So our a here is 1, our b is -4, and our c is 1. So we're going to plug those in. We're going to do a -b, which is going to be 4, plus or minus the square root of b squared. So -4 squared is 16, minus 4 times a times c, all over 2 times a, which is 2. So we're going to get 4 plus or minus root, and what you're going to get there is 12 all over 2. Now we are not done here. We have to break down the 12. So think about how we break down a root 12. Right, we can break that down into 4 and 3. Square root of 4 times 3, a 2 comes out. You get 2 root 3. So now we've got 4 plus or minus 2 root 3 all over 2. Now, this isn't wrong, but we can simplify this a little bit more. We're going to take a 2 out. We get 2 plus or minus root 3 all over 2. Cancel that out. Your answer here is 2 plus minus root 3. So those are going to be your other roots, right? So you're going to get 2 plus root 3, 2 minus root 3. All right? And then if they want the factored form of this, I'm going to do it up here, right? We would do x minus 2 plus root 3, x minus 2 minus root 3, and then, of course, distribute the negative, which is going to give us x minus 2 minus root 3, x minus 2 plus root 3. So that is going to be our factored form there. Then you should have be able to tell the end behavior just from looking at it, right? As it goes to negative infinity, as x goes to negative infinity, the function goes to negative infinity. And as x goes to positive infinity, the function goes to positive infinity. The domain here is going to be all real numbers. And if you see, right, this is odd, so it's going to cover all of the y values. So the range is also all real numbers. All right. Okay, so then we've got, and they already had the graph there, so we don't got to do it. So now we've got number 7. So for number 7 here, they gave us a standard form. All right. So we're going to go ahead and get it into factored form. Now I'm going to show you something new here, right? When you're trying to get this guy into factored form, let's try and take out the greatest common factor, right? If you take the greatest common factor out of x cubed minus 2x, you can take an x out. So you're going to do x squared minus 2. All right. Now, at this point, you have a couple of different options. We know that x is definitely a factor because we got him by himself. But now we've got to factor this guy. So you've got two options here. You could use quadratic formula on this where a equals 1, b equals 0, and c equals negative 2. That would give you the correct answer. However, when b equals 0, okay, you're able to just take the quadratic and set it equal to 0 and solve. It makes things a heck of a lot easier. So if I do x squared minus 2 equals 0, and you can only do this when b equals 0, when that middle term isn't there, you add 2, you get x squared equals 2, and you take the square root of both sides, you do plus minus, so you get x equals plus minus root 2. And that's it. So your other root here is going to be, we've got positive root 2, negative root 2, and then if x is a factor, right, you can set that equal to 0, you get 0. If x is a factor, you know you have a root of 0. All right, very cool. So now the function in factored form, all right, you're going to have x minus root 2, x plus root 2, and x. All right, and then for our end behavior, right, we can just look at our chart. This is an odd degree. Our leading coefficient here is 1. So it's going to go to negative infinity as x goes to negative infinity, and it's going to go to positive infinity as x goes to positive infinity. The domain, of course, is all real numbers. For all polynomials, it's all real numbers. Whoops. And then the range, since it's odd, is also all real numbers. Whenever the polynomial degree is odd, the range is all real numbers. All right. So that concludes that part of the task there. So I wanted to go over a couple of other problems here. So if we look at the readies, the ready is super easy. And I know it looks very intimidating here. But all you're doing is you're canceling out stuff that's on the top and on the bottom. So you're just looking for commonalities here and canceling out everything you can, right? So like, for example, on number 5, I can cancel out these guys. So then on the top, all that's left is x plus 4. We got x minus 1 on the bottom. So that's how you would do number 5. For something like number 2, right, you would cancel out those guys. You can cancel out those guys. You can cancel out those guys. So what's left on top? We got 2xx, 3y. All right, so that is how you do those. Hopefully you know what to do when you have something divided by itself, right? If I gave you like 7 divided by 7, that gives you 1. So, or you could even say like x divided by x, that would give you 1. So keep that in mind as you go through these, all right? I know I told you guys to work on page 74. And as I was looking, I was like, you know, they might have a hard time with the factored form of number 10. So I wanted to help you with that. And oh my goodness, did Did I draw number 7? Oh my goodness, I never drew number 7. Hop back here. Sorry, guys. So for number 7, this is one you actually could do without graphing because there's no imaginary roots, right? We go through 0, 0. And then if you plug root 2 on your calculator, you get 1.41. So you would go right here. And then negative root 2 is negative 1.41. So you would go right there. Okay? So the way that this graph is going to look is it's going to go through here, down here, through there, and up. Sorry, I skipped over that earlier. Probably like, what the heck? All right. So anyhow, hop back to number 10. I wanted to help you with the factored form of this. I figured it would be a little bit tricky. The rest of them you really should be able to answer here. And of course, use Desmos as you see fit. But if someone asks you to factor x cubed, the factored form is just going to be x times x times x, right? That's x cubed. So that is how you would factor that guy. I guess you could also write it with parentheses around there if you wanted. So think about that, right? There's definitely going to be a multiplicity here, and it's going to be a multiplicity we haven't really talked about very much yet. We've done a lot of multiplicities of 2. See if you can figure out what the multiplicity is of number 10. And then one more thing. I wanted to go over number 19 from the Go. Now, people who did not get the packet from me and printed what I posted, I forgot to add in page 77. So if you need to pause the video and go print it, feel free. You could also just do this on notebook paper. We're not doing this part here, so really it's just the work for 18, 19, and 20 that you need to do on notebook paper. But definitely go print it if you want a physical copy. All right, so for this one, it says write the polynomial function in standard form given the leading coefficients and the zeros of the function. So I figured number 19 was going to be a tricky one for you guys, so I wanted to help you out. So first off, if we were trying to write this in factored form, they'd asked for standard form, but we need to write it in factored form first. We would have x minus 1 plus root 3, and then x minus 1 minus root 3, right? And then if we rewrote that with the distribution, we get x minus 1 minus root 3 and x minus 1 plus root 3. Now this is the factored form, right? Oh, and they also told us that the leading coefficient is -1, so we should slap that on there. Now they want this in standard form. This is in factored form, so you need to multiply this out to get it into standard form. Now, I know a lot of people, no, I shouldn't say a lot of people, but someone asked, like, does it matter the order that you multiply them in? No, but I recommended getting rid of the roots and the I values first. So I want to multiply these guys first, all right? So let's go ahead and do that. We've got x minus 1 minus root 3 times x minus 1 plus root 3. So let's go ahead. We're going to have to distribute 3 separate things here. So let's distribute this x. We get x squared minus x plus x root 3. I'm going to run out of space, I think, here. Then let's go ahead and distribute this -1. So you're going to get minus x plus 1 minus root 3. And then we're going to distribute this negative root 3. So you're going to get minus x root 3 plus root 3, and then you get minus root 9, okay? So I'm going to write this out up here so you guys see what I did. Negative root 3 times root 3 gives you negative root 9. Oops. You multiply what's on the inside there since it's the same root, okay? So let's go ahead and simplify this a bit. We've got x squared out in front, and then we are going to end up with a minus 2x here because these guys go together. And then these guys cancel. These guys cancel. And then I've got a plus 1 minus, and then root 9 is 3, right? Square root of 9. So now we've got x squared minus 2x minus 2. All right, so essentially this thing in blue is what this thing equals when you multiply them out. So last thing we have to multiply in is this guy, and then of course our negative out in front. So let's go ahead and multiply in the x minus 1. I'm going to put them out in front. You could also put them in the back. It doesn't matter. So let's go ahead. We're going to distribute this x. We get x cubed minus 2x squared minus 2x. And then let's distribute this negative 1. So we get minus x squared plus 2x plus 2. So these guys end up canceling, and we end up with x cubed minus 3x squared plus 2. All right, and then we also need to take care of that negative there, right? So at this point, all you got to do is distribute the negative, which should be fairly straightforward. You get, hold on. Yes, you get negative x cubed plus 3x squared minus 2. And that would be your final answer there. All right, that was a lot of work, a lot of colors, but that would be your final answer for 19. You're definitely going to run out of some space there. All right, hope everyone has a good weekend.